Welcome students in this video lecture. Today's topic I have selected complex numbers. So in this video lecture we will learn some basic concepts of complex numbers, like how we represent the complex numbers in different coordinate systems, what is the modulus and what is argument. But before that students, let us see why do we need the complex numbers when we have already with us the system of real numbers. Then why do we need the complex numbers? So let us take an example through which we can easily understand the necessity of the introduction of the complex numbers. So suppose you are given with an equation x square plus 1 equals to 0. Then if we try to solve this equation, you will find x equals to plus minus under root of minus 1, and this under root of minus 1 is written as iota. So dear students, this iota, which is the negative under root, does not belongs to the set of real number. That is why we cannot find the solution of this equation or this type of equations in a real number line. That is why we need to introduce a system of numbers where we can easily find the solution of this type of equations. That is why the complex number or set of complex numbers came into the picture. So to include the solution, we need to add this I, means this iota with the real number system. Then it becomes the complex number. So therefore the complex numbers are denoted by Z, and it contains two parts. First part is real, which is associated with the real number, and this additional term we have added which represent the imaginary parts. So it can be written as an ordered pair like x comma y. So x is nothing but this is the real part. So this is the real part of the complex number, and y is nothing but this is the imaginary part of the complex number. Okay. Now we can easily find the solution of this type of equations in the set of complex numbers C, because I can be associated with the complex numbers because this represents the imaginary part. Okay. Now next thing is students, as in the case of real numbers, we can compare two real numbers. Like suppose we have 7, so we can easily say that 7 is greater than 5 or 3 is less than 4. But in case of complex number, we never compare, means comparison is not possible in case of complex number. Means suppose we have given two complex number Z1 and Z2. So we can't say that either Z1 is greater than Z2 or Z1 is less than Z2. Means comparison never possible in complex numbers. Yes, this is not possible in case of complex number. But if two complex numbers are given, suppose Z1 is equal to A1 plus B1I and Z2 is equal to A1 plus B2I, then these two complex numbers will be equal to each other if and only if the real part of Z1 is equal to the real part of Z2 and imaginary part of Z1 is equal to the imaginary part of Z2. So two complex number can be equated only when their corresponding parts, means real part is equal to the real part and imaginary part is equal to the imaginary part. So comparison is not possible, but we can equate them. Now there are some properties which I have listed here. You can see that. Yes. Now conjugate of a complex number. What do we mean by the conjugate of a complex number? Suppose we have a complex number Z equal to A plus IB, then its conjugate is denoted by this, and it is defined as a minus ib. Means if you change the sign of imaginary part in z, then you can get the conjugate of the given complex number. So if z equal to a plus ib, then its conjugate z bar would be a minus ib. Now there are some properties of complex numbers which we are taking here straightforward. Conjugate of sum of two complex numbers is equal to the sum of their conjugate. Difference means the conjugate of difference of two complex numbers is equal to the difference of their conjugate, and the conjugate of the product of two complex numbers is equal to the product of their conjugate. Similarly, in division means conjugate of z1 by z2 is equal to conjugate of z1 divided by conjugate of z2, but provided that z2 should never be 0. If it becomes 0, then we can't define the conjugate of division of two complex numbers. So this is the condition which should be followed. Now what is the modulus, students, of a complex number? Suppose we are given with a complex number z equals to a plus ib, then its modulus is defined by this. This is written as mod of z, and it is defined as the under root of sum of the squares of real part and imaginary part. So this is the modulus of the given complex number. Suppose let us take some numerical problems. Suppose we have given with 2 plus 3i, then its modulus will be 2 square plus 3 square, means 4 plus 9 is equal to 30. So this is the modulus of the given complex number. This is the modulus. Now suppose if you want to find a conjugate of this complex number, so conjugate will be nothing but just you need to change the sign of the imaginary part. So you will get the conjugate of the complex number. Ready? Now there are some properties related to the complex numbers and their modulus. So the modulus of the sum or the difference of the two complex numbers is always less than or equal to the sum of their moduli, and these properties can easily be proved. Now the last one we have to be very cautious. So the modulus of the z1 by z2 is equal to the division of their moduli, but we need to very cautious that z2 should never be 0. If it becomes 0, then we cannot find the modulus of the division of two complex numbers. Now most important thing, how we represent the complex numbers in xy plane. So let us see. So as I have already told you that the complex numbers can be represented as ordered pair. If z equal to x plus iy is a complex number, then it can be written as x comma y, and this can be viewed as a vector whose initial point is at origin and the terminal point is at x comma y. Suppose this is coordinate system x and y axis. Now the point x comma y has been written as p. Then the distance from the origin to the point P is termed as the modulus of this complex number. So this is, suppose OP equal to R, so mod of Z is equal to nothing but this is R. This is modulus. Now suppose this modulus OP makes an angle theta with x-axis, then the projection of this OP over x-axis will be nothing but R cos theta. And similarly, the projection of this OP over PM. PM, what is this? We have drawn perpendicular from P which meets x-axis at L. So the projection of OP over PM will be r sin theta. So this r sin theta is equal to y and this r cos theta is equal to x. So for a given complex number z equal to x plus iy, we can find the value of x and y as a projected values of r. So x will be nothing but r cos theta and y is equal to r, x equal to r cos theta and y equal to r sin theta. So this is in polar form. So if we replace the values of x and y in z equal to x plus iy, you will get z equal to r cos theta plus I r sin theta, and if you take r out, you will be able to write this as exponential, because in exponential e to the power I theta, it is very famous result, it is equal to cos theta plus I sin theta. So further we can write it as e to the power I theta. So in exponential form, the complex number z can be written as r into e to the power I theta, where r is the modulus. So we can replace this r by mod of z. Now dear students, suppose we are given with complex number z equal to x plus iy, then how we can find the argument? Argument means the value of theta. This value that we have already introduced, this theta, how we can find this value of theta for a given complex number? That is called the argument of the complex number, and it is defined at tan inverse y by x. So argument theta is defined as tan inverse of y by x, where y is the imaginary part and x is the real part. So this is called amplitude or argument of the complex number, and the value of this theta which satisfy both the equations means x equal to r cos theta and y equal to r sin theta, that would be counted as the principal value which lies between minus pi and pi. So satisfying both the equations and lying between minus pi and pi, that would be the argument or the amplitude of the complex number. Clear? Yes. So suppose this is complex number minus 1 plus I root 3 divided by 2. So modulus of this complex number can be found easily. How? So if you compare here, you will find that the real part of this complex number is nothing but is minus 1 by 2, and imaginary part of this complex number is nothing but this root 3 by 2. Then to find the argument and the modulus, so we can easily find, so modulus, that is r, is nothing but under root of real part and imaginary part squares. So you will get under root of 4 by 4, that will be 1. Okay. Similarly, we can find the argument of this complex number. To find the argument, we need to write theta is equal to tan inverse y by x. Y means under root 3 by 2 divided by minus 1 by 2. Yeah? So you will get tan inverse of, it would be minus root 3. Okay, so it can be written as we know that tan inverse minus theta is equal to pi minus tan theta. So you can write it as pi minus tan inverse root 3, and tan inverse root 3 is nothing but this is pi by 360 degree, and ultimately you will get 2 pi by 3. So this is the argument of the complex number 2 pi by 3, and 1 is the modulus of this complex number. Okay dear students, thanks for watching, and in the next lecture we will talk some other topics. Thank you for watching.